So I'm back graphing my exponential decay model that we had done before, and technically this was a 5, but we're going to turn it into a t because what we're going to do is we're going to input time values so we can graph it. And t is actually just x, it's what we're putting in, and y is what's coming out, which is output, which is y values. And I put a -1 here just so you can see this, but we'll do this last. So 0.5 to the 0 is 1, and 1 times 20,000 is 20,000. Now when I substitute in 1, what's going to happen is the value of my car is going to go down. So 0.5 to the first is 0.5, and 0.5 times 20,000 is half of that, which is 10. Probably shouldn't write 100,000, but it's 10,000, pardon. And 0.5 to the 2 is 0.25, and 0.25 times 20,000 is 5,000. And 0.5 to the 3 is 0.5 times 0.5 times 0.5. I don't know. I know it's 2,500 though when I multiply by 20,000. 0.125, that's it. 0.125 times 20,000 is 2,500. Took a little bit of time, but I got it. Okay. When I substitute in -1, and this doesn't really make sense because you can't have -1 in terms of time, but staying consistent with exponential functions, it actually is pretty useful to do that. And technically I could substitute it if I want to. So 0.5 to the -1 is 2, and 2 times 20,000 is 40,000. So what happens on an exponential function is when you're going to the left, it gets higher, and when you're going to the right, it gets lower. So we'll start with 0 and 20,000, and each little slash I made is 1,000. But each little slash I made here counts as 1, just to make my graph a little bit more manageable. So at 1 it's 10,000. Right there. And at 2 it's 5,000. And at 3 it's 2,500. It's about right there. And it goes on forever. Now at -1 it's 40,000, which is, I'd have to go further than the camera would reach anyways. But basically what I'm saying is that my graph, my model, looks something like this. It'll extend forever, and it'll keep going down, but it won't ever get below the x-axis. It'll get infinitely lower and lower and lower. Now my car might be a piece of junk, after 20 years, and nobody might want it, but what would happen though is that I could even sell it for parts. So I guess that's the way to think about it. But technically it's never worth 0. It'll always be worth slightly more than that. So when it comes to my exponential decay, it looks like a line except you bend it, and it looks like this, kind of like I say it looks like a J except you reflect it. It's not really true, it doesn't look exactly like a J, but it basically looks like a straight line with a bend in it. So one more thing to talk about is domain and range. Domain are my x values, what I can substitute in, and I can substitute in negative numbers till the cows go home, and I can substitute in positive numbers till the cows go home. So my domain is -infinity to infinity. My range, though, is different. My graph is asymptotic, which means that it will never go below here. It's got a horizontal asymptote. It'll never get to 0. It'll get infinitely closer and closer and closer to 0, but it'll never reach. As my graph extends to infinity, my limit is 0. That's a calculus concept. When we talk about calculus and limits, that'll be explained in more detail. But basically what that means is my graph, my range, my y value will never hit 0. It'll get closer and closer and closer, but never hit. So my lowest value is greater than 0, but not much greater. And my highest value, goes on forever. So that's my domain and range. That's an exponential decay function. That's the relationship of what you do. You do this first, and you plug this into your calculator or into your head first, and then you multiply by 20,000 afterwards. So it takes a little bit of time. Other than that, that's exponents for the most part. I hope that was helpful. Have a good day for now. Goodbye.